So today we are talking about triangle similarity. And there are three different kinds. These are similar to when we did congruent triangles, but there is a difference, obviously, because when we did congruent triangles, angle-angle was not a congruency, but it is a similarity. So if you have angle-angle similarity, that means there are two corresponding angles that are congruent in your triangle. Let's see if I can zoom in on this, because it is very small. Oh, going the wrong way. Alright, that sort of helped, I guess. So we're determining all of these if they are similar by angle-angle. If yes, then we're going to write the similarity statement we talked about yesterday in class. So looking at the first one, angle A is 75. Angle D is also 75. So I have one A. Yeah. Then angle C is 31, and so is angle F. Blah, 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 blah. I have two congruent pair. I have two pairs of congruent angles. There we go. Pairs are weird. So that means this is a similar statement. So if I were to write this, I'm going to go triangle ABC is similar to triangle DEF. Okay, now I've got to do my second one. I've got this angle that's the same, Y, and this angle that's the same, V. But other than that, there's no angles marked. So I'm going to look at what it gives me. I've got this diagonal cross here, which is a pair of vertical angles. In case you forgot about vertical angles, they're still around. So because there are vertical angles here, that means that I have another pair of congruent, two pairs of congruent angles. Pairs are really hard. I don't know why I'm struggling with pairs today. So because I've got two pairs, there is an angle and an angle. So that means this is similar. And I'm going to write my statement. I'm going to start with the V, so triangle V, then I'm going to go to the second set of congruent angles, and that is X, and then my last one, that is nothing, W, is similar to Y, X, Z. So I did that because I followed the similar angles. Kind of the same in number one, but it was way easier to tell. Two is a little harder. You're just going to follow the angles that are the same. So looking at the next one, this is side, side, side similarity. This was similar to something that we talked about in triangle congruency. Only difference is now we're looking at similar, not same. So side, side, side similarity happens if all corresponding sides are proportional, then that means the triangles themselves are similar. So here's how we're going to figure this out. You're going to look at your triangle, and we are going to determine if it is similar by making three different proportions. So I'm going to color code mine. I've got my first side, which is going to have the smallest value. That is kind of how we're going to match these up. So my first side with the smallest value is QP, and that is 3. And then in the next triangle, that would be TS, that has a value of 6. So that is my first one. My second one would be this bottom one right here for 4 and for 8. So if I were to make the proportion for that, it would be 4 to 8. And then my last one is the diagonal part here, and that is 5 to 10. If all of these reduce to the same amount, then that means they are similar. If not all three of them reduce to the same amount, then that means they are not similar. So if I go through this, 3 over 6 reduces to 0.5, 4 over 8 reduces to 0.5, 5 over 10 reduces to 0.5. Because they are all reducing to the same, this is a side, side, side similar triangle. So my similarity statement would be triangle QPR similar to triangle TSU. So looking at the next one, we're going to do the same thing. Start with identifying your smallest side. We're going to say that one is 30 in my first triangle and 24 in the second. Then the next smallest would be 32 and 25. And then the last smallest, aka the biggest, is 35 and 28. So if I go through and I simplify all of these, man, you really can't see that very well. Now we can see it better. If I go through and simplify all of these, 30 over 24 reduces to 1.25. 32 over 25 reduces to 1.28. 35 over 28 is 1.25. All three of these are not the same because of this bad boy right here. So that means this is not a similar triangle. Let's just zoom out. Oh, that's not out. That's zooming in. Here's my next one. Gotta keep moving the document camera, making it seasick. Okay, so my last one is side angle side similarity. That happens if two corresponding sides are proportional and the included angle, remember an included angle is between two sides. The included angle is congruent, then the triangles are similar. So if I look through this, I've got this side here, this included angle here, and then this side here. Now I'm going to do similar things to how I did the side one. I'm going to make proportions for each. So I've got 8 to 6, and I've got 20 to 15. If I reduce my 8 to 6, that reduces to 4 over 3. And if I reduce my 20 over 15, that also reduces to 4 over 3. Because those two are the same and there is an included angle, these are similar triangles by the side angle side similarity. And if I were to name them, that would go triangle JKL is similar to triangle MNP. Doing the same thing for the next one, I've got this little segment here, AE, that's 12. And then I've got the long segment on that same side, that's 21. And then on the opposite side of my triangle, I've got 15 and 25. Now there is an included angle here because angle A is the same in both. So that means that it's the same. But we have to see if these reduce to the same thing. If I look through them, my first one here, my red one, that reduces to nothing. It cannot be reduced. So it would just stay that. And my orange one reduces to 3 over 5 because these are not the same. Oops, I wrote number backwards. This is not a side angle side similar triangle. Okay, if I flip my page, we're just going to practice this a few times together before we move on to the individual practice. So starting with the angle similarity, remember you have to have two angles that are like two pairs of angles, two sets of pairs of angles. Still struggling with this, I don't know why. So looking at number one, because I need two angles that are the same, I've got one here. Angle N is going to be the same in both because it's physically the same angle. But I've got to figure out if either of the other two angles are going to be the same. So in this first triangle, triangle BCN, I've got two of the three needed angles to figure out all three angles. So I'm going to subtract 180 minus 91 minus 67, and that's going to give me angle B. That gives me a value of 28 degrees. 28 degrees and 25 degrees are not the same because they're two different numbers. So this is not. Looking at number 2, I've got these two angles on the opposite sides of each other that are congruent. And then I've also got this lovely vertical angle. Remember, vertical angles are congruent. So that means this triangle, or these triangles, there's two, are similar because of the angle-angle similarity. So this is a yes. And I'm going to go from angle to angle and name it for my similarity statement. So I've got triangle PXQ is similar to triangle ZXY. Remember, I did that by looking at those semicircles and going through and matching one semicircle, two semicircle, no semicircle. Okay, now we're going to go to the side similarities. The side similarities, remember you have to have 3 proportions, one for each side of your triangle, and they all have to reduce or simplify to the same thing. So looking at this first one, I've got my smallest side, 9/14. And then I've got my second smallest side, 13.5 to 21. And then I've got my last smallest side, or my biggest side. If I reduce all of these, the first one would give me 0.64. Second one would give me 0.64. Last one gives me 0.64. They are all the same, so this is a yes. And I actually don't have to name it because that's not what the instructions say. So I'm not going to name this one. We're going to do the same thing for number 4. Remember, I have to have 3 proportions. But there is one thing I have to do in order to find one of my proportions. I've got these two separated values. But in order to figure out the whole WU segment for the bigger triangle, I've got to add them. 20 plus 8 is an easy one, it's just 28. So my first proportion is going to be 20 to 28. Didn't start with the smallest one this time, just because it was easier to start on this left-hand side. My next one will be the smallest one. It's going to be 15 to 21. And then my last one, 40 to 56. All of these, if I put them in the calculator, reduce to 0.71. So this is a side similar triangle. Last but not least is to go back to the side angle side. Remember, for it to be side angle side, it has to be an included angle. That's an angle between two sides. So if I look at number 5, I've got a vertical angle here. Vertical angles are between two sides, so I've got the A. I have to determine now if I've got the S's. So to figure out the congruent pieces, I've got to look at, I need a different color. I've got to look at the smallest two sides. The smallest two sides here are FE and ER. They connect to make this line, so I can kind of double check myself to make sure they've connected to make that line. So I've got 6 to 24 for one of them. Now my second one would be this other side, 12 to 48. Both of these reduce to 1/4. Because they are the same and there is that included angle, this is a yes. This is a side angle side similar triangle. Looking at number 6, here is my vertical angle, but it is the only congruent angle I've got. If I'm looking at my sides, the shorter one is this one way over here and way over here. And then my longer one is this one here. Because this purple is not between my orange and my red, kind of like it was in number 5, this is no. It cannot be side angle side if it is not an included angle. That angle needs to feel included by those two sides, not left out. Okay, looking at number 7, it is very similar to how I did number 4. I've got to calculate the sides because I only have the parts of the side and not the whole long side. But because it is an overlapping triangle, this angle here, angle W, is going to be my included angle. So far I've got the A. Let's see if we've got the S's. So to calculate my first side, I'm going to start with the smaller side. Got 14. And I got to calculate that whole long one. 28 plus 14 is 42. Then to do the same thing on the other side, I've got 15. 15 and 30 is 45. Both of these reduce to 0.3. So I do have two S's, and I do have an included angle, so this is a S. Remember, when you're doing similarity statements, you're just going to follow the congruent sides or angles, if we were to write these for all of them. If you have any questions, make sure you get with your teacher. Have a great day, y'all.